welcome everyone. My name is Kamil Trzcinyki. I am from GitLab. I am currently a staff developer at GitLab. With me is Timo and Ralph. Timo has a bunch of stickers for you, so he gonna let it pass through the hall. So today's presentation, I was thinking about what I could tell, maybe something interesting, something different. And I got to the point that you often have a lot of tutorials, quick start guides, how to do something with GitLab CI, how to run some pipelines, but there is hardly anything that would describe you something like some more advanced concepts, like how to make it your CI performant. Maybe this is something that you're not thinking about at the beginning when you do that, because you strive just for having that quickly running, having something to show. But as soon as your team grows, as soon as your number of people involved in the project grows, it's becoming more and more urgent. Like, to give you some example, at GitLab, we have GitLab CE, and for every commit, we basically run 27,000 tests. Like, we test pretty much everything for every commit. It's so massive amount of the compute, and it has so big implications on our productivity that it's basically crucial that we constantly focus and try to optimize. So I was first thinking that this is about understanding, but it's more about mastering your knowledge, about figuring out some of the aspects that you could think when you create your pipelines. So we actually have a lot of these buzzwords. We have GitLab CI, GitLab CD, we have also DevOps. It's kind of maybe confusing. Okay. It's gonna be like that. We are back. It's kind of confusing because it's not really kind of clear what it's all about. At GitLab, we actually describe the GitLab CI, but it become much more than only GitLab CI. We actually try to make a single application that covers all these aspects. When you start with the kind of proposal idea, proposal of the change, maybe the of the feature, and you end up on having this change on production server, but not only that, you also think about what is beyond that. Might change the land on production, but this is not the end of the story. You want to also monitor that. So you also need to be aware how your change affects your system over time. And GitLab tries to build some kind of intelligence behind that to make it much easier for you. And also another aspect is you hear that pipelines are everywhere, and they are, because if you look at the products, you have Travis. Travis doesn't really have pipelines, they have build stages, but it's pretty similar to pipelines. You have Bitbucket. Bitbucket has pipelines. You have Jenkins, which introduced pipelines, and everyone is pipeline, and you could actually think that you can describe every process using pipeline. And if you look at this CI pipeline, CD pipeline, to be fair, it's basically the pipeline, the whole pipeline, just the only pipeline that describes a sequence of actions that you execute and maybe somehow parallelize. In this case, you could think about this whole graph as something that describes how your change travels from the code to production. But CI/CD tries to cover these two aspects that you have, that you test, verify, but then also review your application of maybe staging environment, then do that in production. It's gonna be like that. Make it maybe. Yeah, no, it's okay. There is I don't have a lot of text on slides, so I can talk. Maybe have that change on production, and beyond that, you have these monitoring capabilities. So the full reason why to do that is you want to have the confidence in the system. You want to automate things. You want to reduce the human errors. And you want to, in the end, ship fast and deliver more often and deliver much more. So the purpose of having the CI in the first place. You want to basically have everything managed and automated. And this is not only about just testing, but also about long-term VT of the project. You want your project to be maintainable over time, and CI and CD basically helps with that. So if you want to start with GitLab CI, it's basically simple. Pretty much everyone right now has like some CI YAML configuration file. It was basically like proposed first by the Travis. They were like precursors of all this concept. And it's also quite simple to do that at GitLab. The most important things are basically shown on this snippet. It's basically stages. You define a sequence of the operation. Stage is kind of like a gate. So the workload will not be processed from the workload from another stage. The next stage will be not the process until everything in this stage is being finished. And like syntax for defining a job for your stage, it's also quite simple. You define a name, you define a stage, you define what you want to execute. But in order to run these CI jobs, you basically need a runner, which is like kind of central piece for us. There is a picture of how a GitLab-runner architecture looks like. GitLab, because of the way how it works, and just because we stray for massive scale multi-tenant, is built with the principles of massive scalability and with the principle of multi-tenancy. So everything that we do at GitLab, we think on how it can run for hundreds of thousands of millions. It has some implications because in some cases it's only possible to optimize workflow if you optimize it for the specific use case. So in some cases, GitLab CI may be slightly slower because we have a different attention. But what is important, GitLab is very flexible to give you a lot of control over what is happening. And I will show you a few examples. So where to get GitLab-runner? You can use ours on gitlab.com, shared runners available for free, or you can install your own. It's crazy easy. There is like a bunch of different packages that you can put on your server, or on your VPS, or maybe on your bare metal. And the first question that you're gonna be asked when you install your runner is basically executor. And executor is actually something that describes, maybe not describes, it runs your CI jobs. It defines a methodology. The executor defines a kind of constraints that you have to follow to make it basically, to make your CI have some specific behavior. So if you look at the executors, we pretty much offer like this three most popular that pretty much covers, I think, 99% of use cases, which is shell. You probably know that running things on the directly on server, on the terminal. Why shell is important and why it's important to have shell? Because Docker is not everywhere, Kubernetes is not everywhere, and we have a lot of customers just running Xcode iOS builds on their Macs, and shell is the only way to achieve that. But for everyone else, the Docker and Kubernetes are the most convenient ones because Docker and Kubernetes allows you to abstract, allows you to provide a clean environment for each of your job and puts the control of this environment in hands of developer, not the administrator. Administrator basically has to provide you the resources, but developer decides in the end what they want to use. So the purpose of that is you want to be faster, you want to make it more performant, you want to make it easier to manage. And why choosing Docker? Because, I mean, it's not about choosing Docker, it's more about choosing the philosophy of containers, like we are on the container days. And like there is like a lot of buzz about Kubernetes now. And it's equally useful using Docker and Kubernetes. But Docker did actually provide a kind of workflow, did provide a solution to the workflows that you may want. How to quickly build the image, how to quickly be able to replicate that, how to quickly be able to put that in hands of the developer. And one of the biggest things that Docker Hub offers is basically this rich set of the images that are provided for you for free, basically. Usually in the past, you would just do apt-get update, apt-get install Ruby, or something like that. But today, we would basically specify image Ruby 2.41 or something different, and maybe add extra steps to conform to our requirements of our application. It's convenient, it's easy, it's in the hands of the developer, but like following this standard path, it's also not really performant. And the second trouble is that very often CI environment is, there is a video. Very often CI environment, even if you use Docker, if you use containers, it's not equal to what you run locally. And sometimes it's really hard to figure out what is happening. So one of these challenges is like, we want to solve that in like very clean and fancy way to give you like ability to enter the terminal of the running job straight from GitLab, so you don't need, I don't know, any SSH keys to be able to run somewhere, because your CI job can be running on the Kubernetes. But it's not really possible yet today. So we do offer something like gitlab-runner exec. Gitlab-runner exec is a extension of the GitLab-runner, a tool that runs your CI jobs. And exec make it possible to run everything locally on your computer the way that CI runs. There is, of course, some bunch of limitations, because runner exec does not support everything. It does not support, for example, artifacts or caches. But I know that there is like a lot of people using that basically for prototyping. It's really like much faster that you modify just GitLab CI YAML, do GitLab runner exec with saying, I want to run that on Docker executor and the job test, and get a feedback much quicker than like pushing commit to GitLab and getting that from the interface. But like, it optimizes our workflow, like it optimizes the way how we can figure out the commands, but it doesn't really help with the speed of the pipeline on GitLab itself. So it's actually kind of tricky, because we usually choose Ruby images that are we choose Docker images that are very large. And if you go to Docker Hub and search for the image, you often see that there are like different variants. There is like Ruby, Ruby Slim, Ruby Alpine. And what is the difference between them? Basically, Ruby normal, regular, and Ruby Slim are based on the same system, which I think right now is Debian Stretch. But the Slim variant actually removes all packages that are not related to Ruby. But it also means that it removes all development packages. So it kind of results in kind of crypted image that it's very small, but pretty much doesn't have anything. So you still have to install everything in order to use that for the test purposes. But then you kind of end up in the situation that this Ruby Slim image is like probably even more than the 700 of the regular image. And this is where we have Alpine. So maybe if we have Alpine, maybe we could use Alpine Linux. And Alpine Linux is quite interesting Linux distro, because it's not based on glibc, but it's based on Musl. But it's very minimal too. It's very small, it's very efficient. Also, the size of all dependencies that you have to install, they are like a magnitude smaller than the ones that you get from Debian. And mostly works. I mean mostly because all developers usually use Debian-based system. Maybe they use Arch, maybe they use Fedora. So basically, always use the glibc-based systems. And very rarely they use Alpine. But with Docker, there is like big shift on reducing the footprint. If you consider like using Alpine for testing purposes, it's kind of becoming quite interesting, because it's very likely that you want to use also Alpine image for building your application image, because this image gonna weigh probably like a few hundred megabytes less than that would the same image on regular distro weight. And it's convenient because you are testing the same application, basically, using the same runtime for your CI, but this is also the same application that you are using for deploying and running in the production. And it has this kind of implication that if you run on the production, pulling image has very big implications on time. It's really basically not today I/O bound, but more like a CPU bound, because Docker images, the layers, how they are transferred, they are basically tar-gzip, and it's very likely that you are CPU bound on just uncompressing this transferred image. But also, it's not very trivial to update your application to the Alpine, because it requires some quirks. For example, I had to Google, and I found on Stack Overflow this build config Nokigiri use system libraries. It was not something that was very easy to guess what to do, and required a few tries and errors. But the results of just doing that was astonishing, because my pipeline runtime did shrink from like 5 minutes to 3 minutes, which is like, it's not negligible difference. Even that I had to install all these dependencies. And installing all these dependencies could be even abstracted away, because you could prepare the image ahead of the time and use this image always. So, but how to figure out that, like this magic, basically? Usually just you fire the Docker shell on your terminal and you try to replicate these commands and then like copy paste them to GitLab CI YAML. In 99% of the cases, this is exactly how it's gonna work, and this is exactly how you're gonna be able to iterate quickly. Like the worst case would be, like the worst idea would be basically, I'm changing my CI and I'm pushing that to GitLab to figure out whether it's working or not. It's like the cycle time of getting this feedback, it's minutes instead of seconds, basically. So let's talk more about the runner, because there is also, as I said, we optimize for like different aspects that you may be optimizing. And it's very crucial to answer a few questions, a few decisions that you want to make to understand the implications on security versus flexibility. Because if we run things on gitlab.com, we put in front always security of our customers. So we don't want data to be exposed to unprivileged users. It costs a lot in terms of the performance, but maybe you can make this trade-off. Maybe you trust the code of your coworkers. Maybe you don't have. Maybe these projects can basically share some things. Maybe just because they can share, maybe you can run these builds concurrently on your server. Maybe, like another case, running distributed system is not very performant if you like building Android sources. Like you are pulling 10 gigs of images, 10 gigs of repos, and you are producing 40 gigs of the artifacts. Maybe you basically need some different approach to handle your use case. GitLab allows you to have this kind of flexibility. And there is like a set of general rules that you want to follow always. Like, if I look, for example, at Ruby and RSpecs, most of our Ruby code is basically single-threaded. Most of our processes are multi-threaded. So, like, we are wasting so much compute. Not really compute. We are wasting so much unused capacity of our systems that maybe we can basically increase parallelism of our project and use vertical scaling of our runner to say to runner, hey, but you have 6 cores. You can basically run 10 jobs at a single time. Maybe it's from the same project. Maybe it's from different projects. It doesn't really matter. For us, it helped a lot that we are able to monitor our CI. Basically, just because we are running in the cloud, we very often see a CPU still time being like a key factor of variance between the build times. We had a situation when everything was like the fastest possible. Our pipelines would finish in 15 minutes, but sometimes jobs that basically took 25 minutes to finish. And it was basically because of the shared nature of the cloud hosting. And pretty much achieving that with GitLab it's very simple because in terms of the parallelism, I mentioned about the pipelines. You basically define more CI jobs in the given stage. Pipeline, is it gated? Stage is gated, so, but everything that is within the stage, we execute in parallel, if it's possible, if you have the runner capacity. And it's really simple, basically, to increase this vertical scaling. You basically specify, hey, I want to run 5 concurrent jobs to be running at single time. Then also, like the next step would be, I want to scale horizontally, which is really cool because your workflow becomes platform agnostic. You are more resilient to failures. And by the nature of GitLab-runner, you basically have high availability solution very easily because it doesn't matter on which machine you run the workflow because the environment is controlled by the developer, not by the administrators or infrastructure providers. So you are free to do whatever you want in terms of the scaling. You can use auto-scaling at the next, basically, if you have if you want to run 100 or 300 jobs at single time. This is something that we do at GitLab that we, at idle times, we have, I don't know, about 50 jobs running, but in the peak times, we basically process up to 2,000 jobs at the single time. And system basically figures out the right amount of the machines to process all of that quickly. So I mentioned about the caching, and caching is always hard, and probably even harder is like invalidating caching. But GitLab-runner also gives you a few different possibilities on having the caches right for your project. So the simplest one, and there is no magic in the caching. If you register GitLab-runner and you register Docker executor, you basically get a volume/cache defined in your config tome. Why we did find that? Because the cache volume is the folder that is mounted to your CI job running on Docker. And each your project receives the unique cache folder. So this cache folder is not shared between projects, but is shared between jobs. It's kind of handy because you get native performance of accessing this cache folder because this cache folder is stored on your disk. But you basically can be more efficient in maybe caching bundle gems in the cache folder instead of the local folder. And also, if you say that my cache folder, I don't want it shared between only the single project. I want this shared to be between all my projects, like the same cache folder. Maybe I want it to be shared between all my runner managers. So maybe this cache folder is on some NFS server. It's with this hostbin mount specification, it's possible to instruct runner to say, always bind cache to the cache folder of the CI job. In cases of this kind of massive caching situation, maybe like this Android example, it makes a lot of sense because pulling data from the cache is very expensive. When you use GitLab cache, we offer GitLab cache, which allows you to use this easy syntax cache paths with the folder, local folder to your directory. But it has a few drawbacks, and these drawbacks are that GitLab cache uses zip archive to store the data, and a zip archive is regenerated every time a file is changed compared to the previous zip archive. And for large archives, probably more than 100 megabytes, basically it doesn't scale anymore. And if you use distributed GitLab cache, it works pretty much the same, but we transfer this zip archive to object storage. Because by distributed, we mean we don't really know, we don't have affinity volume between different machines. Our only central point is maybe GitLab and the object storage from which we can pull and push data. But a few words about cache and artifacts. It's kind of interesting because a lot of people from issue reports that we receive, we know that they are misusing cache for passing data between stages. Why it's basically wrong idea? Because cache, by definition, is something that can go anyway, any moment, for whatever reason. You are running out of the disk space, so which is basically the first thing that we do. We just remove all the caches. Like, maybe you don't need them, we don't know. But also, let's consider another example that you have a pipeline with a lot of stages, and you did build your application, but you do deploy like 10 days later. How likely is that your cache gonna have the accurate data of the previous job running 10 days later? It's very likely that you're gonna end up with mismatch deployment to production. And from different angle, this distributed aspect, like if we want things to be distributed and we know that the single pipeline may be executed across different runners on different platforms with different configuration, artifacts basically are the only thing that allow us to make it fluid from the user perspective, like expectations of the users, but in the trade-off of the performance of the artifacts, because we have to transfer that to GitLab and then we have to transfer that from GitLab. And it's very often costs a lot of traffic. And why it also get confused? Because probably we miss the third concept. And people consider also always artifacts in context of Jenkins, that they are like binary artifacts as the result of my pipeline or my job. And artifacts right now, from perspective of our users, serve this kind of dual purpose, because on one hand, use artifacts for passing between stages, but on the other hand, use artifacts for releasing your binaries of your pipeline. So it's kind of maybe confusing, but it was meant to be created this way, to create this distinction, to optimize for scale rather to optimize for speed. But as I can show you, as I did show you with the cache, it's kind of possible to do that quite more efficient. So another like a big topic is Docker builds. I know that we use a lot right now that we build Docker images, and there is so much different approaches to that. I even talk about Dint on like with some people yesterday or day before. And we also have this JPetazo GitHub post from 2015, which is saying that Dint is a terrible idea. It's hard to disagree with him, but there are cases where Dint is basically preferable, and it's probably like the most convenient from the perspective of your CI requirements also. Why is that? Because it's also another thing. People are confusing Docker Dint with Docker on Docker. Docker on Docker is basically the concept of using your host Docker engine in your CI job. But it has a lot of small quirks that you need to be aware. Using Docker on Docker causes the problem that you may accidentally kill your CI job, because you run in the same shared environment as your any CI job. But also another problem is that you are having problems with the parallelism, because let's consider that you have two CI jobs building the Docker image of the same name. You don't really know which one finishes first and whether you're gonna be able to push that to container registry, because you're running on the shared environment, on the shared resource without any kind of semaphore or locking on the resource that you are using. So basically, Docker in Docker, in most cases, give you better kind of like behavior of the system at the cost of the performance. To be fair, it's equally insecure as Docker on Docker, because with Docker on Docker, you basically can do anything, the same as with Docker in Docker. But basically, it scales terribly well. Like, it scales always. It's kind of imperformant, but you can make the performance of Docker in Docker slightly better if you use basically cache from. And what is about the cache from? Basically, it's the idea that you pull the image that you built previously to Docker in Docker, and when you build this image, the new image, you basically specify, please try to reuse layers from my previous build. It costs slightly more because you have to pull the image, you have to unpack, and there is this CPU IO intensive operation. but it's very likely that you're gonna reuse like probably 80 or 90% of the layers of your Docker build, and you're gonna push basically maybe 2 or 3 small resulting layers to the container registry. So in the end, it's more performant if you do cost from, and it's much easier from the developer perspective because you can do whatever you want with Docker, and you are sure that you never break someone else's workflow. And how to enable Docker in Docker? We are very flexible, maybe sometimes too flexible, because you are in the full control of what is happening in what kind of workflow you want to use. Basically, the main requirement is to use privileged true, so you kind of like make your containers be able to do everything. It's insecure, but as I said, you need to make some trade-off. You need to figure out what kind of security you need. And then you specify, I want to use service Docker dint. There is this optimization argument Docker driver to use much more efficient overlay for a system. And basically that's it, and you can use any Docker command from your CI job. And for Docker on Docker, it's even simpler because you just specify a volume, and you just start using Docker. That's it. But I'm just thinking, come on, we are just replicating these commands so often and so much. Maybe there is just basically a better way. GitLab is very flexible because it gives you so much freedom, but with the freedom, it comes that like it's sometimes not optimal, and maybe we could like make GitLab CI, make a hint to GitLab CI that we want to use the Docker. I mean, we want to use Docker for running containers, or maybe we just want to use Docker just for building images, and hint GitLab that, hey, I want actually Docker for building. Please provide me a kind of secure Docker engine that's gonna be secure, that's gonna have like, I don't know, shared val-lib Docker, so all my previous images. And maybe this is the way to actually make the users' experience much better at the cost of like still giving you the ability to define that differently, to use the previous syntax, but make it easier to make this managed by gitlab-runner to figure out the best way to run your Docker-related things. So that's it. Thank you very much. If you want to talk with us, we have a few minutes left for the Q&A. You will be able to find us around the coffee place at the meet. There will be Timo and Ralph, and time for questions.